So I thought I would do a short video on the probability starter that was on one of the lessons, as I had a number of questions about it and people seemed a little bit confused as to what they were supposed to be doing. So I thought I'd just quickly record a quick video going through the questions. So the first one, an ordinary coin is tossed. Now this should be fairly straightforward because there are two options when you have a coin. You can have heads or you can have tails. So the probability that I get a head, I can only get a head one way unless it's an unfair coin. So, and I have two different outcomes, heads and tails. So the probability that the coin lands on heads would be 1 out of 2. Now an ordinary dice is thrown. What is the probability that the dice lands on a prime number? So there's two parts to this question. We need to know what a prime number is. And on a six-sided dice, they are 2, 3, and 5. So how can we get a 2, a 3, and a 5? How many ways? Well, a dice obviously has 6 sides, if we're using a six-sided dice, and each side has a different number on it, between 1 and 6. So I can get a 2 one way, 1 out of the 6 ways. I can get a 3 1 out of the 6 ways, and I can get a 5 1 out of the 6 ways. So we could add them all up. So 1 out of 6 for 2, 1 out of 6 for 3, and 1 out of 6 for 5. So if we added them all up, that would give us 3 out of 6. And we always need to remember to simplify. So that would be a half. Now, unfortunately, I haven't got a pack of cards to show you, but Anita picks a card from an ordinary pack of 52 playing cards. Now, playing cards often come up in questions, so if you try and maybe understand what are in a playing card, like you have 4 suits, you have the jack, the queen, and the king. So how many ways can we pick a king? Well, only 4 cards out of the whole 52 are kings. So there is only 4 ways that we can pick a king out of the 52 cards. And this simplifies further to 1 out of 13. So half the problem with the probability questions is understanding what it is that they're actually asking us to do and knowing that a pack of cards only contains 4 kings. The next question, a class contains 18 girls and 15 boys. One of the students is selected at random. Calculate the probability that the student is a boy. Well, the first thing we need to know is how many people are there altogether? How many girls and how many boys put together are there? So that is 18 add 15. And 18 add 15 gives us 33. So we have 33 people stood in a room. Now, out of those 33 people, there are 15 boys. So I have 15 ways I can pick a boy out of the people that are in the room. So that's 15 out of 33. And that simplifies to 5 out of 11. Okay, so for our next question, we have fish that are in a fish tank. And there are 8 guppies, 5 platies, and 7 mollies. So again, we need to know how many fish do we have in our fish tank. So we have to add all the different fishes up together. And we have 20 fish that are swimming around in our fish tank. Now we want to know the probability of picking a guppy, and the number of ways that we can pick a guppy is 8 because there are 8 guppies in the fish tank. So that is 8 out of 20. So 8 out of the 20 fish are guppies. So we have an 8 out of 20 chance of picking a guppy, but we can simplify that to 2 out of 5. The next question, Jack has cans of soup which don't have any labels. He knows that 3 of them are tomato, 4 of them are mushroom, and 7 of them are chicken, but he doesn't know which ones are which. If he picks a can at random, what is the probability that the can chosen is not tomato? Now, there's a couple of different things about this question. First of all, we need to know how many cans of soup he has altogether. So we need to add them all up. So we have 3, 4, and 7. So equals 14. So we have 14 cans altogether. Now, the second important part of this question, and this is all the way through probability questions, is understanding what the question is asking you. And they're often worded in quite an ambiguous way, and you need to work it out what it's actually asking you to do. So this question wants to know the probability that the can he picks is not tomato. So that is the real crucial part of it. We could look at this two ways really. We could either work out the probability that he picks a tin of tomato soup, and then we use our 1 minus whatever the probability was to work out the probability of not picking. So the probability that he picks tomato, well, there are 3 cans of tomato, so he has 3 ways he can pick a can of tomato soup out of 14 cans. So if we then did 1 minus, because remember it's mutually exclusive, one event is not dependent on the other, and when we take this probability away from 1, that will give us a probability of it not happening. So the probability of it not happening is 11 out of 14. The other way you could do it is to add up the probability of picking the other cans. So the probability of picking a can of mushroom, well, there are 4 cans of mushroom and there are 14 cans altogether. And then chicken, well, there are 7 cans of chicken out of the 14 cans altogether. So if we add these together, so that is also the same. That is the probability of picking a mushroom or a chicken tin of soup, which is the same as not picking a tin of tomato soup. So this bag contains red counters and blue counters, and we want to know the probability that a counter selected is blue. So we need to know how many counters we have altogether in our bag. So that's 3 add 2, which equals 5. So we have 5 counters all together. So picking out a blue would be 2 out of 5. We have 2 chances of picking out a blue counter out of the 5 that are in our bag. Now the next bag contains red counters, green counters and blue counters. What is the probability that a counter selected is either red or blue? Now again, there's kind of 2 parts to it. So we need to know what our total is. How many counters do we have in our bag? So that's 2 add 5 add 4, which equals 11. And then the next part of the question says find the probability that the counter selected is either red or blue. So that's the important part. It's either red or it's blue. That's like on our dice question with the prime, it's either a 2, a 3 or a 5. So the probability of picking out a red counter, well, there are 2 red counters out of the 11. And the probability of picking out a blue counter, well, there are 4 out of 11. So we just add them together. And that becomes 6 out of 11. Because or is adding them together. It's red or it's blue. So you add the probabilities together. And that becomes 6 out of 11. Then we have the next question. A bag contains 4 red counters, 7 blue counters and 5 green counters. One of the counters is selected at random. Find the probability that the counter selected is not blue. So again, we need to know the total number of counters that are in our bag. So that's 4 add 7 add 5 equals 16. So we have 16 counters that are in our bag. The question says find the probability that the counter selected is not blue. So that's the important part, it's not blue. So if we look at it again like we did with our tin of tomatoes, the probability that we pick a blue counter is 7, because we have 7 counters in the bag out of 16. Therefore, 1 minus 7 out of 16 gives us a probability that it's not a blue counter, and that would be 9 out of 16. So the answer is 9 out of 16. The other way we could have done it is to work out the probability of picking red, which would be 4 out of 16, and the probability of picking a green would be 5 out of 16. If we added them together, that would give us the probability of picking either a red or a green counter and not a blue one. So you can see they are both the same. So the next question says, a letter is selected at random from a set of letters. Find the probability that the letter M is selected. So how many letters are there? And there are 11 letters. How many ways can we pick an M? 2 ways. So the answer is 2 out of 11. There are 2 ways of picking an M out of the 11 letters. And this is a similar one. A letter is selected at random from a set. So these are the letters. Find the probability that a vowel is selected. So how many letters are there? Well, there are 11. And a vowel is A, E, I, O, or U. They're the vowels. So we have an O, we have an A, we have an I, and we have an I. So there are 4 ways out of the 11 that we could pick a vowel. Obviously, that question relies on the fact that you know what a vowel is. And you often find this with probability questions. You need to know more than just being able to calculate the probability. So the final question, each month of the year is written on a card and placed in a bag. One of the cards is selected at random. Calculate the probability that the month written on the card has 30 days. So you need to know how many months of the year have 30 days. Well, 30 days has September, April, June and November. So we know April, June, September and November. And we know that there are 12 months in a year. January, February, March, April, May, June, July, etc., etc. So there's 4 ways that we can pick a month that has 30 days out of 12 months in a year. So we simplify that and that equals 1/3. But again, that is relying on the fact that A, you know how many months there are in the year, and you know how many days are in each month. So there is more to knowing the question and being able to answer it than just knowing how to calculate the probabilities. I hope that helps.